The male cone is driven by a one-way clutch, stainless steel needle-bearing clutch. I mentioned that the parts run dry, but if by chance you had a spool off and water were to enter the drag chamber, that's not a problem, because if water gets on the drag surfaces, it still behaves the same way. It doesn't change the braking property of the drag. If it's salt water that enters the drag chamber, again, there's no materials in here that should corrode. Everything's stainless or non-corrosive otherwise. In fact, we ask that you don't perform any kind of maintenance, that you don't lubricate the drag. Oil on these surfaces will degrade the performance of the drag. So just simply in maintenance, mount the spool so that the drag is sealed, and then rinse the reel in fresh water. And that's all the maintenance that's required. So the results in putting all this together in the drag system is that you have a drag that is incredibly smooth because of the properties of the material, incredibly smooth across the entire range of torque. Unlike other materials where when you dial in more torque, more stopping power, you get less smooth performance in the drag. That doesn't happen in our drags. And when you put it all together in a sealed system with the materials that we're using, it's zero maintenance. I'll come back and talk about how the drags are scaled in the various models in our reels. Let's talk about another objective in more detail, which is mechanical simplicity. All of our reels have just a little bit more than 20 parts. Again, and I said, all things being equal, fewer parts or greater simplicity is better than complexity. And maybe saying that in a different way, the more parts you have, the more can go wrong. Also, the more parts you have, the more physical weight you're going to wind up with, and that's contra to one of our other objectives. Give you a couple of examples of mechanical simplicity. All of our reels have the same type of locking mechanism that locks the spool onto the frame. Contrast that with a typical design in other reels. In other reels, you have a button or a latch that you're engaging that has springs and plates sliding internally, grabbing a nipple at the end of the spindle. That's a very common design. You see that still today across many, many brands. When we purchased Lamson from Sage in 1998, there was a well-known model of Lamson made at the time called the LP. We continued to manufacture that for a few years, so we're quite familiar with the design of that reel, and it's a very conventional design. It had that type of latching mechanism, spool to frame. There were 11 parts, I believe, or maybe 12 parts in that single function on the LP, and again, that's typical for other manufacturers using that same design. So that's a lot of parts to serve one function. You create an opening for material to enter the running part of the reel. We used to see LPs with grit and so on getting into the running part of the reel, scoring the bushing, etc. So the design is a liability by the opening and the number of parts. In our reels, we have a wide collar machined in at the base of the spindle. That collar passes through an O-ring at the entrance to the drag chamber and then sets into a machined groove behind the O-ring inside that Delrin cap. So on all of our reels, when you press across the axis of the frame and spool, you hear a pop or a snap. That's the compression of the O-ring as the flare at the base of the spindle passes over the O-ring and locks into the chamber. Now the spool is on. It created that function with no extra parts. You need a spindle, you need an O-ring to seal the chamber. It's just the relationship of those two parts that you already need anyway to create the added function. So in the case of the LP, there's eliminating 11 parts. Another example of simplicity, counterbalances on reels almost always are a slug of material opposite the handle, equaling the handle weight. Well, there's a couple of parts associated with that. There's a place where line can snag. There's a part that can corrode or fall off. In the case of all of our designs other than Guru, we utilize some other solution that requires no additional parts. In the case of the Waterworks, the additional mass of the opposing spoke opposite the handle, both outside and inside, the click housing, the mass of the click housing as well, that additional mass equals the weight of the handle. No additional parts required. In the case of light speed, the counterbalance opposite the handle is the mass of the click housing inside the spool opposite the handle. No additional parts. Velocity, it's the mass opposite the handle machined into the spool flange. And conic, it's the additional mass of the opposing spoke opposite the handle. On the new Vanquish, same thing, additional mass of the opposing spoke. So those are some examples of how we've reduced the number of parts in reels, our reels, to a little bit over 20. A typical reel would have 50, 60, 70 parts or more. The LP had 86 parts. Fewer parts means greater reliability over time and less physical weight. Another objective I mentioned was to utilize superior materials. Give you some examples of how we do that in our reels. First, the spindle and the spin knob axle, the fastener that runs through the spin knob on our reels, all of our reels, is 17-4 super alloy. And I'm not making up that term, that's actually the term for the material, 17-4 super alloy. That material is 3 times harder than standard marine grade stainless, and it's actually stronger than titanium. I mentioned the materials that we use in our drag system, the male cone. It's not off the shelf. We spent 18 months developing that material, this alloy, unique in our reels. We finish our reels with what we call hard allox. Hard allox is a proprietary combination of mechanical preparation of the aluminum surface, a chemical preparation in addition to the mechanical preparation, and then a type 3 hard anodize. Virtually every other reel that you'll see in the world uses what's called type 2, or in the industry, anodized industry, is called a decorative finish, type 2. And as we all know from experience with reels, a type 2 finish is very soft. You can penetrate that finish and get down to the bare aluminum quite easily. So it doesn't serve the function. It looks good in the case. That's why they call it decorative. You can make it green, blue, red, shiny, dull, semi-gloss, whatever. It's the good analogy in my mind for type 2 finish is to think of it as paint. It's not paint, but it's a bit like that in the sense that you can determine exactly what color and what sheen of finish you want on that reel. But again, it doesn't serve the function well over time. So we use a different finish, as I said, hard allox. It produces a finish that is comprised of much harder material and a much thicker surface. And the combination of harder material and thicker surface means that it's a much better protection for the aluminum. This is a demonstration. This is the aluminum that we use, 6061 alloy, done in a hard allox finish. And I'm taking a metal bottle opener and I'm scraping that finish with some force. And if you were to do that on a type 2 finish, you would see aluminum immediately. You'd scrape right through the finish. On our finish, you're seeing a surface mark, which is actually the metal coming off on the finish. And if I take Scotch-Brite and I rub it, those surface marks go away and you're left with the original finish. So it's very, very difficult to breach or penetrate a hard allox finish, and therefore, we're creating a better functional finish for our reels. Another example of superior materials.